Welcome to viewers again. Here we will discuss some properties of proportion. These properties will be widely used in geometry. Later on you will find that some of these properties will be very useful in solving geometrical problems. So let's discuss here. The first property is invertendo. Now if A is to B proportional to C is to D, that means A by B equal to C by D. Now we can invert this B by A equal to D by C, or B is to A proportional to D is to C. This property is called invertendo. Just we are inverting the ratio. It becomes, the antecedent becomes consequent, consequent becomes antecedent, right? You are just inverting the fraction, so it is called invertendo. Say for example 2, 4, 8 and 16. 2 by 4 equal to half, 8 by 16 equal to half. Therefore 2 by 4 equal to 8 by 16. Now if you invert this ratio, 4 by 2 equal to 16 by 8, this becomes, each of this fraction becomes 2 by 1, 2 by 1, right? So we write it as 4 is to 2 proportional to 16 is to 8, right? This is called invertendo. Next is alternendo. A is to B proportional to C is to D. That means A by B equal to C by D, right? Now if you cross multiply this, A into D equal to B into C. Now you see, if you multiply both sides by, say for example DC, AD by DC equal to BC by DC, it becomes D and D cancel each other, A by C equal to C and C cancel each other, B by D. So A is to C proportional to B is to D, right? This is called alternendo. That means you are altering the means. If you are altering the means, it becomes same. So this property is called alternendo. Say for example 2 is to 4 proportional to 8 is to 16. Now let's check 2 is to 8. We are altering the means. 2 is to 8. What is 2 is to 8? 1 by 4. And 4 is to 16. What is 4 is to 16? 4 by 16 means 1 by 4. So you find that 2 is to 8 proportional to 4 is to 16. That means you are altering the means, right? So this property is called alternendo. Next property is, you see, if A is to B proportional to C is to D, or A by B equal to C by D. Now let's add 1 both sides. Now this becomes LCM B, A plus B equal to C plus D divided by D, or A plus B is to B equal to C plus D is to D. This property is called componendo. Componendo, right? Now let's prove this. 2 is to 4 equal to proportional to 8 is to 16. Now you see, A plus B, 2 plus 4 divided by B. What is this? 6 by 4. This becomes 3 by 2. B plus C plus D, C plus D, C plus D divided by D. 16 plus 24 divided by 16. 8 3 is 8 2 is. That means 2 plus 4 divided by 4, A plus B divided by B, C plus D divided by D. They are same, right? So this property is called componendo. Next property is dividendo. A by B equal to C by D. Let us subtract 1 from this. A by B, subtract 1 from both sides. Now LCM is B here, A minus B, D, C minus D. So you got A minus B is to B equal to C minus D is to D, or C minus D is to D. That is A minus B is to B proportional to C minus D is to D. This property is called dividendo. Now let's prove this. 2 is to 4 proportional to 8 is to 16. Now you find A minus B, 2 minus 4 divided by 4, A minus B divided by B, minus 2 divided by 4 equal to minus half. C minus D, 8 minus 16 divided by D, C minus D divided by D, minus 8 by 16, this means minus half, both are same. So 2 minus 4 divided by 4 equal to 8 minus 16 divided by 16. That means 2 minus 4 is to 4 equal to 8 minus 16 is to 16. This property is called dividendo. Now if A is to B proportional to C is to D, we find that A plus B divided by B equal to C plus D divided by D. This is called componendo. And A minus B divided by B equal to C minus D divided by D. This is called dividendo. Now let's divide these two. Divide left hand side by left hand side. Dividing 1 by 2. Dividing this relation by second relation. That means A plus B by B divided by A minus B by B equal to C plus D by D divided by C minus D by D. This becomes A plus B by B multiplied by B by A minus B, C plus D by D multiplied by D by C minus D. Now B and B cancel each other. Here D cancel each other. We got A plus B by A minus B equal to C plus D by C minus D, or A plus B is to A minus B equal to C plus D is to C minus D. This property is called componendo and dividendo. Since you got this relationship by using componendo and dividendo, right? So this property together with componendo and dividendo, we got this property. So it is called componendo and dividendo. Now let's use this property with this relationship. 2 is to 4 proportional to 8 is to 16. Now A plus B, 2 plus 4 divided by A minus B, 2 minus 4. 6 by minus 2 equal to minus 3. C plus D, 8 plus 16, C minus D, 8 minus 16, 24 divided by minus 8 or minus 3. So both are same. That means this property is true. A plus B, 2 plus 4 by 2 minus 4, right? A plus B by A minus B equal to C plus D by C minus D, right? Proportional. Now let's discuss one more property. This is addendo. Now what is addendo? Let's discuss here. Addendo. This is another property. A is to B proportional to C is to D. right? That means A by B equal to C by D. Now these ratios are equal to A plus C divided by B plus D. You can use this property in more numbers of ratios. Say for example, A by B equal to C by D equal to E by F equal to Z by H, etc. Then you will find that sum of the antecedents A plus C plus E plus Z, etc., B plus D plus F plus H, F plus H, etc. That means these ratios will be equal to sum of the antecedents divided by sum of the consequents. Now let's prove this. Suppose let A by B equal to C by D equal to E by F equal to Z by H equal to say for example K. Now you find that A equal to BK, C equal to DK, E equal to FK, Z equal to HK, right? Now A plus C plus E plus Z divided by B plus D plus F plus H equal to, what is A? A equal to BK, C means DK, D means E means FK, plus G means HK. Now divided by B plus D plus F plus H. You can take common here, K, B plus D plus F plus H divided by B plus D plus F plus H. These two cancel each other, answer is K. That means this ratio is also K, and these individual ratios we compared with K. Therefore A by B equal to C by D equal to E by F equal to Z by H equal to A plus C plus E plus G divided by B plus D plus F plus H, right? Means each ratio will be equal to sum of the antecedents divided by sum of the consequence, right? Now we will try to use the properties of ratio in solving a geometrical solution. Let's try to solve this equation problem. In this triangle ABC, AD by DB equal to AE by EC. AD by DB equal to AE by EC. This line divides these two parts proportionately. The sides AB and AC proportionately at point D and E. Now prove that AB by DB equal to AC by EC, AB by AD equal to AC by AE. Now let's try to prove this with the help of the properties of proportion. That means we will try to use alternendo or invertendo, componendo, dividendo, this type of property. So let's solve this. Solution. Here AD by DB equal to AE by EC. This is given, right? Given. Now AD by DB, let's add both sides 1, AE by EC plus 1. This implies LCM will be DB, AD plus DB, AE plus EC divided by EC. So which property we are using? Componendo. A plus B by B equal to C plus D by D. This is the componendo. Now what is AD plus DB? This is AB by DB. What is AE plus EC? AC by EC. So first one is proved, right? Now let's try to prove the second one. Again you see, given that AD by DB equal to AE by EC. Now we have to prove this AB by AD equal to AC by AE. That means we want to convert this AD into denominator, AE into denominator. This might be consequent. We want to invert this. So using Invertendo, we can write it as DB by AD, EC by AE. Using Invertendo, we try to use here Invertendo, means inverting the ratio. Now let's do one thing. Both side 1, adding 1 both side. Adding 1 both side. Now you see this AD, DB plus AD, AE, EC plus AE. So here we use Componendo. We are using here Componendo. Now this becomes DB plus AD. DB plus AD means AB by AD equal to EC plus AE. EC plus AE means AC by AE. So we prove the second one, right? That is how we can use the properties of ratio in solving problems like this. We will discuss similar use of the properties of ratio in solving geometrical solutions. Thank you for watching.